We move on to the last question in this 2023 senior team paper, which reads as follows. Consider a square ABCD. The square is drawn, as you can see on the side here. A rabbit hole is located at point A, and this is where the rabbit hole is. And initially, two rabbits sit at points B here and D, respectively, and a fox at point C. The rabbits can run along the lines AB and AD. Now watch, it's AB and AD, so that it's the full lines. They can run anywhere along this line with a speed at most 1 meter per second. Just bear that in mind. The speed that the rabbits are capable of is 1 meter per second. The fox can move freely on the plane. The foxes can move anywhere. With a speed of at most v, the fox is also constrained, cannot travel indefinitely at any high speed, but it cannot travel at more than the speed than v, meters per second. All right, now the fox catches the rabbit if it arrives simultaneously at the same point as the rabbit. Well, so if the rabbit is moving and the fox is moving and they both meet, they will meet somewhere along this line. Then the fox catches that rabbit. And it says that including the point A. Right? So if they both meet at the same point, including this point here, the rabbit hole, then we say that the fox has caught the rabbit. All right, and the rabbit, of course, escapes if it reaches the hole before the fox. Now, the question is now, find the minimum value of V permitting the fox to catch both rabbits. So in other words, what must V be, which is the maximum speed that the fox can attain? What must that be in order for it to catch both the rabbits? All right, so let's have a look at this problem. Now, there are actually, we have to assume that the rabbits are going to develop some kind of a strategy and the fox also a strategy. And we have to say from the outside what their best strategy is. And at the same time, it is not for the rabbits and the fox to think, it's for us to think about this problem. Okay, so let us first say that the side of the square is A. Let's call it A. So A is the side of the square. And this is also A here. I have written A and it's rather small. Okay, now there are a couple of possibilities. The first possibility I would suggest is that the rabbits both move towards the rabbit hole to escape, while the fox, I suppose both of them move towards the rabbit hole simultaneously to try to escape the fox. Then what must the fox's speed be in order to catch the rabbits? Okay, at the critical stage, you will catch the rabbits both right at the time when they are about to escape. Okay, so we have to consider that case. So to do that, so the problem is, what must the speed of the rabbits be so that when this guy travels this distance and this guy travels this distance, which by the way is A, right? They will take a time T. Both of them will take the same time because both of them are traveling the same distance, it's the side of a square, at the same speed. This time, both of them traveling at 1 meter per second. So what must the rabbit speed be in order to be at the hole at exactly the same time as the fox's speed, I'm sorry, be exactly the same time as when the rabbits get there. Okay, now in this case, the time taken by the rabbits we can calculate it because we know what the distance is, the distance the rabbits traveled to get to the hole, and we know what the speed is. So it's A seconds. And we want the fox to also be there A seconds at that rabbit hole after he starts off. But the best strategy for the fox is to travel in a straight line. That's the shortest distance between 2 points. He's going to minimize the distance he travels. And in this case here, you can use Pythagoras to decide what this hypotenuse is. This is the hypotenuse of a right angle triangle. So that distance can be calculated. And if you calculate using Pythagoras, the distance is A root 2. So we have in this case here the V that it travels, speed times time is equal to the distance. So we want this A, which is the time that the fox takes, must be the same as the time that the two rabbits take. The fox, his distance is A root 2, and his speed is, we are asking about what V is, the best speed. All right, so here you can see immediately the A's cancel and V is square root of 2, which means that square root of 2 is approximately 1,414 meters per second. So when in this case, if the fox travels at that speed, you will reach the rabbit hole at the same time as the two rabbits reach there, and you catch them. All right, so this is the case where both of them travel towards the hole. Okay, so the speed is 1,414. Okay, now there are other possibilities. Which are open to the rabbits. They can, for instance, they can both move away from the rabbit hole. But this is a very poor strategy because they've got no place to hide. Right? The rabbit hole is now not in sight. So, but it may be a possibility because now it makes it difficult. Both of them are moving away from, and the fox would probably have to travel at a very fast pace to catch both of them. But that's not quite true because in this case here, all the fox has to do is to travel at a speed which is faster than the maximum speed of the two rabbits. So in this case here, v can be chosen to be greater than 1, anything, like v equals 2 or something. All right, so because then this fox is traveling faster than the rabbits. He can move this way. Yeah, we can assume he's got all the time in the world. He can move in like this and go up there. He's traveling faster. So he must catch the rabbit somewhere. And in the meantime, this guy has gone quite far away there. But the fox really doesn't care. He just comes down here maybe, and follows him. He's traveling faster than the rabbit. And the rabbit has got no place to hide. So he would catch this rabbit as well. So the second case is quite easy. So there's one case which remains, and that is where one of the rabbits say, oh, look, we can name these four vertices. It's not big enough here. So this is B, this is the C, and this is D, and this is A. So we can call this rabbit here, we'll call it the B rabbit, and this is the D rabbit, right? Although we got the names B and D as the points, but we just by abuse of notation, we'll call this the B rabbit and this is the D rabbit. And the fox, of course, is C. Okay. Now, the case which we still need to consider is where the one rabbit decides to run away as far away as possible from the hole, but the other rabbit says, well, I think I can make it to the hole in time, right? Now, the fox is here. So what does the fox do? One is going up that way and the other is coming towards this. You might think that he must come here first and then go there. But I don't think that strategy works. But so I would say that he must go and catch that rabbit first and travel at a fast enough pace to catch the rabbit so that this guy doesn't get to the hole. At that time, the fox catches the rabbit. He's still some distance from the hole. And then the fox dives down to catch him. But he'll be quite happy to catch him just at the critical moment. And that should be the one that we are going towards, because we are trying to optimize the problem. So the fox must dive down to this and meet this rabbit exactly at the spot. So to recap, the fox goes after this rabbit, catches it, and then goes downwards, while this guy travels up and catches him at the right spot. So what must V be in this case? Okay, so that is the problem. All right, so what we do is we will say that we have to give a name to this distance where the distance traveled by rabbit B at the time he gets caught. Now, normally we would put an X here, which is the unknown distance. But I find that it's much better to call it AX, some fraction of the side of the square. A fraction may be greater than 1. but whatever it is some multiple of the side. So I'm going to say, you can see it's very small writing here. I'm going to say that the rabbit gets nabbed at this point here, which is AX away from D in the direction opposite the hole. So this diagram here is a diagram that expresses this state. Okay. So let's take this thing one at a time. Let's look at the scenario where the fox catches this rabbit at a distance, AX. So here, the both of them will travel at the same time because they both leave here at the same time. And when they get caught, they have traveled. When the rabbit gets caught, it travels at the same time. The time that it is on the road, as it were, is the same as the time for the fox. So the t's are the same. The speed here is 1 meter per second, and we know the distance is AX that the rabbit travels. So the time that the rabbit takes is distance over time. I mean, distance over speed. This is the speed, 1 meter per second, is going to be the same as the time that the fox takes. Now, here you've got A this way and the AX this way. So again, if you invoke Pythagoras, you've got square root of A squared plus A squared X squared, like the square of this. So you can see why we call it AX, because now we can take out the A, you see. We can remove the A out from here. So this distance that the fox travels divided by his velocity, you can take this square root of A squared out and A squared into 1 plus X squared over that speed. This is the speed that the fox is going to travel so it can catch both rabbits. And this is one equation that you have. And the A's cancel. And in this case, you have that B. If you cross multiply, you got Bx equals square root of 1 plus X squared. So you have V is equal to this thing in this case. So this is the speed that the fox must travel in order to catch this. But remember, the speed here is still has to be determined because he has to catch the other rabbit. Right? So what happens here is that this guy is traveling at maximum speed to get to that spot there. And this guy is traveling at maximum speed to get to that. So he also will cover the same distance. Right? Because the maximum speed is 1 meter per second. They travel at the same speed, right? And therefore they would be traveling the same distance, these two rabbits. So this is where rabbit D is when rabbit B is there. So now this is the scenario. You've got B is here, D is here, and C is also here because they both, C has just caught B here. So now this guy has to go down and reach this spot at the same time that this rabbit takes to get to that spot. Right? So again, when they meet, they have traveled the same time. We are now taking it time starting from when this guy leaves that spot and where this guy continues towards the haven, the rabbit hole, where you can escape. Okay, so the time is the same. Now, what distance does the fox have to travel? He has to travel this full length here, A and AX. So he has to travel A plus AX. That's the distance he has to travel to get to the rabbit hole. And the fox's speed is still V. This is maximum speed. He's going to travel, he's going to run at this as fast as he can. And that's the time that he takes. And this must be the same as the time that this rabbit takes to get to the rabbit hole. Now, the entire length is A, this is AX. So the distance that the D rabbit has to travel is A minus AX. That's the distance that he still needs to cover, and he's still traveling at his maximum speed, which is 1 meter per second. So this is the time that the rabbit takes, and this is the time that the fox takes. All right, and then again, the A's cancel off. You'll see you got 1 plus x over v equals 1 minus x over 1. So you get v over 1 is equal to 1 plus x over 1 minus x. And there you have it. You have got two values for v, and you got one unknown now, namely the square root of 1 plus x squared over x is equal to 1 plus x over 1 minus x. Okay, so this is the v that we seek, right? Well, it's x that we seek, and once we've got x, then all you have to do is to substitute in this equation here and get the v that we're looking for. All right, we don't like square roots, so let's square on both sides. And you have 1 plus x squared over x squared equals 1 plus x all squared here over 1 minus x all squared. And that is 1 plus 2x plus x squared. The denominator is 1 minus 2x plus x squared. And you can cross multiply. Right, you've got 1 plus x squared there times 1 minus 2x plus x squared is equal to, this way you get x squared into 1 plus 2x. I want to get to an equation involving x, so I have to remove all these signs, all these brackets. And when you do that, you can see the x to the fourth, for instance, disappears. This is a fourth degree equation. X to the fourth, x squared times x squared, and here too. So that disappears, but the cubic term doesn't disappear. Right? I'm not going to expand all this, but this is what you get eventually when you simplify this. This x cubed minus x squared plus 2x minus 1. Now, unfortunately, I don't know whether I'm correct in my argument or not, but using my argument, I came to this. And this thing doesn't have, it doesn't factorize this cubic polynomial. And it's got one root. In fact, it's got exactly one root, because when you analyze this cubic polynomial, it's an increasing function, right? It starts from below the x-axis and goes to above the x-axis. So somewhere along the line, it cuts the x-axis, and that is the root There's only one root, one real root. And how do you find that root? Okay, if it doesn't factorize, and if you can't use the remainder theorem, you try to use the remainder theorem, it doesn't work. So there is another technique which is called the Newton-Raphson technique, which allows you to calculate the root fairly accurately up to maybe any number of decimal places. But when you do that, you see that x is equal to 0,432. Or you can ask Google or AI to solve this. They will do it. Although you're not allowed, in the competition, you're not allowed to use this calculator. So there was something amiss in the framing of this problem. Anyway, so this is x, and then when you substitute x into that, this x here, you get 2, I think you get 2,52 meters per second. So this is the optimal speed. At this speed here, the rabbit not only catches this rabbit which is running away from the hole, but at the same time, it just barely managed to catch this guy when he just reaches the hole, this hapless rabbit. All right, so this is the solution to this problem. The stated solution is 1 plus square root of 2. I didn't get that. Mine is 1 plus square root of 2 is 2,414 approximately. So the stated solution says it's smaller than the one that I had obtained. Well, maybe there is a strategy that the rabbits can take in order to minimize the chances of being caught, and the same likewise to maximize the fox's chances of catching the rabbits. All right, but we'll have to stop there. Okay, let me show you the same solution that I had worked on. So you can have a look at this. And there it is. You come right to the bottom. You got the same 2,52 meters per second. And if you didn't understand what I said, then you can go and read the solution and get a better understanding of it. Well, thank you very much for listening.